Hello friends, in this video we will see about bond order. What is bond order? What is the relation between bond order, bond length and bond enthalpy? Some important points regarding bond order and the tricks to find bond order for less than and equal to 20 electrons and for greater than 20 electrons. At the end of this video, you will be able to solve all the questions regarding this topic. Let's proceed. First question, what is bond order? Bond order is nothing but the number of bonds between two atoms in a molecule. For example, N2, N triple bond N. The number of bonds between two nitrogen atoms in the N2 molecule is 3. Therefore, the bond order is 3. Second question, what is the relation between bond order, bond length and bond enthalpy? Bond order is inversely proportional to bond length. As the number of bonds increases, the bond length will decrease. Bond order is directly proportional to bond enthalpy, which is directly proportional to the strength of the bond, which is directly proportional to the stability of the molecule. Whenever the bond order is increasing, that is, the number of bonds between two atoms is increasing, the energy required to break the bond also will increase. That is, bond enthalpy will also increase. Thus, the strength of the bond will increase. Thus, the molecule becomes more stable. Third one, some important points regarding bond order. 3 is the highest bond order. Isoelectronic species have same bond order. What are isoelectronic species? The species having same number of electrons. For example, F minus, neon, Na plus. All the 3 species will have 10 electron each. Next point, as the number of lone pair increases, bond order will decrease. How to find number of lone pairs? I already uploaded a detailed video on how to find hybridization and number of lone pairs. The link is given in the description box. Check it out. Let's solve this question. Find the order of bond order for CH4, NH3, H2O. So, how to find the order of the bond order? We know that as the number of lone pair increases, bond order will decrease. So, first let us find the number of lone pairs. The number of lone pairs in methane is 0, in ammonia is 1 lone pair, and in H2O there are 2 lone pairs. Therefore, we know that as the number of lone pair increases, what happens to the bond order? It will decrease. Therefore, methane will have highest bond order. Next, ammonia. The order will be methane greater than NH3 greater than H2O. This will be the order of the bond order. Next point, if bond order is equal to positive, the molecule will be stable. If bond order is equal to 0, the molecule doesn't exist. If bond order is equal to negative, the molecule doesn't exist. Let's see the trick to find bond order. For less than and equal to 20 electrons, we have 2 tricks. And for greater than 20 electrons, we have 1 trick. Trick number 1. For less than and equal to 20 electrons. First trick, using the molecular orbital theory, that is MOT. C2. Each carbon atom has 6 electrons. Thus, C2 will have 12 electrons. N2. Each nitrogen atom has 7 electrons. Thus, N2 molecule will have 14 electrons. CO. Carbon monoxide. The number of electrons in carbon is 6 and in oxygen is 8. Thus, carbon monoxide molecule will have 14 electrons. Don't panic seeing the big formulas. You will understand this topic clearly when I solve the questions. For less than 14 electrons or for equal to 14 electrons, you have to use this particular formula. For greater than 14 electrons, you have to use this formula. For less than 14 electrons or for equal to 14 electrons, use sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px equal to pi 2py, sigma 2pz, pi star 2px is equal to pi star 2py, sigma star 2pz. For greater than 14 electrons, for example O2, each oxygen atom has 8 electrons. Thus O2 molecule will have 16 electrons, which is greater than 14. For these types of species, you have to use this formula. For these species, you have to use this formula. Nitric oxide, NO. Nitrogen atom has 7 electrons, oxygen atom has 8 electrons. Thus, NO molecule will have 15 electrons. Sigma star 1s, sigma 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px is equal to pi 2py, pi star 2px is equal to pi star 2py, sigma star 2pz. The orbitals without star, that is sigma 1s, sigma 2s, pi 2px equal to pi 2py, sigma 2pz, those types of orbital denote the bonding molecular orbital. The orbitals with star will denote the anti-bonding molecular orbital. For example, sigma star 1s, sigma star 2s, pi star 2px is equal to pi star 2py. These types of orbital which has the star will denote the anti-bonding molecular orbital. Using this formula, we have to write the electronic configuration. After that, we can find the bond order using this formula, half into Nb minus Na. What is Nb? Nb is the number of electrons present in the bonding molecular orbital. Na is the number of electrons present in the anti-bonding molecular orbital. For exams like NEET and JEE, each and every time you can't write this formula and apply the electronic configuration and apply this formula bond order is equal to half into Nb minus Na. It is going to be a hectic task. To find the bond order in seconds, you can use this trick. You can use this diagram to find the bond order in seconds. The x-axis denotes the number of electrons and the y-axis will denote the bond order. Let's solve a question to understand this graph better. Nitric oxide, NO. Nitrogen atom has 7 electrons and oxygen atom has 8 electrons. Thus, NO will have 15 electrons. So, now let us see the graph. For 15 electrons, what is the bond order? 2.5. The bond order of nitric oxide is, bond order is how much? 2.5. Let's solve another question for N2. Nitrogen atom has 7 electrons, thus N2 will have 14 electrons. For 14 electrons, what is the bond order? 3. Thus, what is the bond order of N2? Bond order is equal to how much? 3. Trick number 3. For greater than 20 electrons, you have to use this formula. Bond order is equal to number of bonds between two atoms in all the resonating structure by total number of resonating structures. Let's solve some questions based on bond order. Question number 1. Find the pair of species that have identical bond order. This question was asked in NEET 2017. In this question, they are asking the pair of species that have identical bond order. We know that isoelectronic species have same bond order. So here we have to find the isoelectronic species among the four options. Those species will have the identical bond order. So let's find the isoelectronic species. What are isoelectronic species? The species having same number of electrons are called isoelectronic species. First option, carbon monoxide, nitric oxide. Carbon has 6 electrons and oxygen has 8 electrons. The CO molecule will have 14 electrons. Nitric oxide, nitrogen has 7 electrons and oxygen has 8 electrons. Thus, NO molecule will have 15 electrons. Second option, O2. Each oxygen atom has 8 electrons. Thus, O2 will have 16 electrons. NO plus. Nitrogen has 7 electrons and oxygen has 8 electrons minus 1, which gives 14 electrons. Third option, Cn minus. Carbon has 6 electrons and nitrogen has 7 electrons plus 1, which gives 14 electrons. Carbon monoxide. Carbon has 6 electrons and oxygen has 8 electrons. The CO molecule will have 14 electrons. N2. One nitrogen atom will have 7 electrons. Thus N2 molecule will have 14 electrons. O2 minus. Each oxygen atom will have 8 electrons. Thus O2 minus will have 17 electrons. Here in third option, Cn minus and CO are having the same number of electrons, that is 14. Thus, these two are the isoelectronic species. Therefore, they will have the identical bond order. The answer for this question is third one. Third option is the answer. Second question, identify the correct order of bond order. This question was asked in NEET 2015. First of all, let us find the number of electrons for O2 minus, O2 and O2 plus. Each oxygen atom is having 8 electrons. Thus, O2 will have 16 electrons, O2 minus will have 17 electrons and O2 plus will have 15 electrons. Firstly, the trick number 2. For 17 electrons, what is the bond order? The bond order is 1.5. Therefore, O2 minus, what is the bond order of O2 minus? 1.5. For 16 electrons, what is the bond order? The bond order is 2 for 16 electrons. Therefore, the bond order of O2 is 2. For 15 electrons, what is the bond order? The bond order is 2.5 for 15 electrons. Therefore, the bond order of O2 plus will be 2.5. Therefore, the order of bond order of O2 plus, O2 and O2 minus is O2 plus greater than O2 greater than O2 minus. Therefore, option number 2 is the answer. I am going to solve the same question using trick number 1. First of all, find the number of electrons for O2 minus, O2 and O2 plus. After finding the number of electrons, you have to check whether the number of electrons are greater than 14 or less than 14. For less than 14 electrons or for equal to 14 electrons, you have to use this particular formula. For greater than 14 electrons, you have to use this particular formula. See how to remember these two formulas. These two formulas are same, but there is only one difference. In this formula, sigma 2pz is coming after pi 2px is equal to pi 2py. But here sigma 2pz is coming before pi 2px is equal to pi 2py. This is the trick to remember these two formulas. If you know this formula, you can write this formula by your own. Let us find the bond order for O2 minus. O2 minus is having 17 electrons, which is greater than 14 electrons. So you have to apply this particular formula. So let us apply sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px is equal to pi 2py, 2, pi star 2px is equal to pi star 2py, 2 here 1. After writing this, you have to check whether 17 electrons are there or not. So let us check. 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10, 10 plus 2, 12, 12 plus 2, 14, 14 plus 2, 16, 16 plus 1, 17 electrons are there. So this is the configuration for O2 minus. So now you have to apply this formula. Bond order is equal to half into Nb minus Na. What is Nb? Nb is the number of electrons present in the bonding molecular orbital, and Na is the number of electrons present in the anti-bonding molecular orbital. Those orbitals which are present without star, these are the bonding molecular orbitals. The orbitals which are having star, the star symbol, these are called the anti-bonding molecular orbitals. So let us apply that formula. Bond order is equal to half into Nb minus Na, which is equal to half into, let us calculate the number of electrons in the bonding molecular orbital. Here 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10. 10 electrons are there in the bonding molecular orbital, and 2 plus 2, 4, 4 plus 2, 6, 6 plus 1, 7. Totally 7 electrons are present in the anti-bonding molecular orbital. So 3 by 2 is the answer, which is 1.5. Therefore, the bond order of O2 minus is 1.5. Let us find the bond order of O2. O2 is having 16 electrons, which is greater than 14. So you have to apply this formula to find the bond order of O2. Let's write the formula. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px is equal to pi 2py, pi star 2px is equal to pi star 2py. Here one electron, here one electron. After writing this configuration, you have to check the number of electrons. Here 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10, 10 plus 2, 12, 12 plus 2, 14, 14 plus 1, 15, 15 plus 1, 16 electrons. So it is matching with this electron. So what we wrote is right.
Now we have to apply the formula bond order is equal to half into Nb minus Na. What is Nb? Number of electrons present in the bonding molecular orbital, and Na is the number of electrons present in the anti-bonding molecular orbital. What are the bonding molecular orbitals? The orbitals which are not having the star is the bonding molecular orbital. The orbitals which are having star, these orbitals are the anti-bonding molecular orbitals. With star means anti-bonding molecular orbital. Without the star means bonding molecular orbital. Bond order is equal to half into Nb minus Na. Let us calculate the number of electrons in the bonding molecular orbital. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. Which is half into 10 minus 2 plus 2, 4. 4 plus 1, 5. 5 plus 1, 6. Half into 4, which is 2. Therefore, the bond order of O2 is 2. 2 is the bond order. O2 is paramagnetic since it is having 2 unpaired electrons. Calculate the bond order of O2 plus. O2 plus is having 15 electrons, which is greater than 14. Again, you have to apply the same formula, this formula. So let us write the formula. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px is equal to pi 2py 2. Here pi star 2px is equal to pi star 2py. Here 1 electron, here 0 electrons. These are the anti-bonding molecular orbitals. Let us calculate the bond order using the formula half into Nb minus Na. Number of bonding electrons are 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10. 10 minus number of electrons in the anti-bonding molecular orbital, 2 plus 2, 4, 4 plus 1, 5. So totally 5 by 2, which is 2.5. Therefore, 2.5 is the bond order of O2 plus, and it is also paramagnetic in nature since it is having 1 unpaired electron. The bond order of O2 minus is 1.5, for O2 is 2, for O2 plus is 2.5. Therefore, the order of bond order is O2 plus greater than O2 greater than O2 minus. Therefore, option number 2 is the answer. Let's see the next question. Identify the correct order of bond length. Bond order is inversely proportional to bond length. Therefore, the order of bond length will be just opposite to the order of bond order. That is, O2 minus is greater than O2 greater than O2 plus. Therefore, first option is the answer. Fourth question. Which of the following will have highest bond order? Option number 1, Cn. Option number 2, CO. Option number 3, Cn plus. Option number 4, NO. Carbon has 6 electrons. Nitrogen has 7 electrons. Therefore, Cn will have 13 electrons. Here in carbon monoxide, carbon is having 6 electrons. Oxygen will have 8 electrons. Therefore, 14 electrons. Cn plus, carbon will have 6 electrons, nitrogen will have 7 electrons, here plus charge, so you have to subtract, so 12 electrons. Nitric oxide, nitrogen will have 7 electrons, oxygen will have 8 electrons, therefore totally 15 electrons. After finding the number of electrons, use trick number 2 to find the answer in seconds. For 13 electrons, what is the bond order? 2.5. Therefore, the bond order of Cn will be, bond order is 2.5. For 14 electrons, what is the bond order? The bond order is 3. Therefore, the bond order of carbon monoxide will be 3. For 12 electrons, what is the bond order? 2. Therefore, the bond order of Cn plus is 2. For 15 electrons, what is the bond order? 2.5. Therefore, the bond order of NO is 2.5. Among the 4 options, carbon monoxide is having the highest bond order, that is 3. Therefore, option number 2 is the answer. Fifth question, identify a molecule which doesn't exist. This question was asked in NEET 2020. To solve this question, we have to use this particular point. If bond order is 0, the molecule doesn't exist. If bond order is negative, the molecule doesn't exist. Therefore, let us calculate the bond order for all the 4 options. Let us calculate the number of electrons for all the 4 options. First one, C2. Each carbon atom has 6 electrons. Therefore, C2 molecule will have 12 electrons. Second option, O2. Each oxygen atom is having 8 electrons. Therefore, O2 molecule will have 16 electrons. Third option, He2. Each helium atom is having 2 electrons. Therefore, He2 molecule will have 4 electrons. Lithium 2. Each lithium atom is having 3 electrons. Therefore, lithium molecule will have 6 electrons. After calculating the number of electrons, apply the trick number 2. Calculate the bond order using trick number 2. For 12 electrons, what is the bond order? 2. 2 is the bond order. Therefore, the bond order of C2 molecule is 2. For 16 electrons, what is the bond order? 2 is the bond order. Therefore, the bond order of O2 molecule is 2. For 4 electrons, what is the bond order? The bond order is 0. Therefore, the bond order of He2 molecule is 0. For 6 electrons, what is the bond order? The bond order is 1. Therefore, the bond order of Li2 molecule is 1. Here the bond order of helium-2 molecule is 0. Therefore, this molecule doesn't exist. Therefore, the answer is third option. Third option is the answer. Sixth question. Find the bond order of PO4 minus 3 molecule. PO4 minus 3 molecule is having greater than 20 electrons. We are using the trick number 3. What is the formula to calculate bond order? Bond order is equal to number of bonds between any 2 atoms in all the resonating structure by total number of resonating structure. To find the bond order of PO4 minus 3, first of all we have to draw the resonating structures of PO4 minus 3. Then we have to apply this formula to find the bond order. See how to draw the resonating structure of PO4 minus 3 molecule. Central phosphorus atom surrounded by 4 oxygen atoms. Next step is to check the charge. Here -3 is the charge, therefore in 3 oxygen atoms you have to put negative charge. In the remaining oxygen atom you have to put a double bond. This is the first resonating structure of PO4 3. The next resonating structure of PO4 3, phosphorus is the central atom surrounded by 4 oxygen atoms. The pi bond from this position will move to this position. In the remaining 3 oxygen atoms, you have to put the negative charge. The next resonating structure of PO4 3, phosphorus is the central atom surrounded by 4 oxygens. The pi bond from this position shifts to this position. And in the remaining 3 oxygens, you have to put the negative charge. The next resonating structure of PO4 3, phosphorus is the central atom surrounded by 4 oxygen atoms. Okay, the pi bond from this position shifts to this position. And in the remaining 3 oxygen atoms, you have to put the negative charge. If this pi bond is going to shift from this place to this place, we will again get the first structure. So PO4 3 is having 4 resonating structures. Let us apply the formula. Bond order is equal to number of bonds present between any 2 atoms in all the resonating structure by total number of resonating structure. What is the total number of resonating structure? 1, 2, 3, 4. 4. Number of bonds between any 2 atoms. So I am taking this phosphorus atom and this oxygen atom. How many bonds are present between this phosphorus and this oxygen? 2 bonds in the first resonating structure. In the second resonating structure, we have only 1 bond between these 2 atoms. In the third resonating structure, again 1 bond is present between this phosphorus and oxygen. And in the fourth structure, again 1 bond is present between this phosphorus and oxygen. Therefore, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5. The bond order is 5 by 4. Therefore, option number 2 is the answer. I have 2 requests for you. First of all, if you haven't subscribed already, please consider doing so because making such video requires a lot of time and effort, and subscribing by just 2 seconds makes up for all. Request 2 is share this video to your friends.